Uh, if you just scroll down, you can see it.
Mm-hmm. Yeah. So okay, so that's one
I was
problem
able to
solved.
download it yesterday.
What is that?
Oh, I went to the site, and while it did have me log into my account and stuff, it did get me to the page, and then I downloaded the
Okay.
the stuff.
All right. Okay. So there's that textbook problem solved. Um, Diagram solutions. So, like I said, these are the kinds of diagrams I expect you to draw. So in the second chapter, Knowing the Heavens, there is a section which talks about the stars that never set, stars that never rise, and stars that rise and set. So this is something you may not have thought about, but um, there are some stars in the sky that never set. For example, the Big Dipper. The Big Dipper never sets. The constellation Big Dipper never sets. You may not be able to see it in the daytime because of the, light in the sky, because the sky is so bright. You may not be able to see it, but it's somewhere there in the north direction. Okay. It never goes under the horizon. Um, so those are stars that never set. The North Star never sets. It's always there in the sky in that direction. It just becomes invisible because the sky is bright. As soon as the sky becomes dark, you can see it again. However, there are other stars that rise and set. So suppose you want to see the constellation Andromeda. There is a constellation Andromeda and you want to see it. You may go out in the night sky and look at the sky. You may not find it. You may look up some star maps or something and find out that this will rise after 2 hours. So that is a star, or another common one, Orion. Orion is something that rises and sets. Okay. And then there are stars that never rise. So within the very southern part of the sky, this is called celestial sphere. Just like we have a globe of the earth, the whole sky is sometimes imagined to be a transparent globe which has stars embedded on it. It's not true. It's not true that that's how the sky is, but just for representation purposes, we kind of make a globe of the stars. And so there is a north, there is a south, there is a north celestial pole, there is a south celestial pole, and so on. So towards the south end, there are some constellations like Southern Cross. Those never rise. So if you live in Wisconsin for all your life and only look at the sky from here in Wisconsin, there are some constellations you will never see, like Southern Cross and other ones. Those will always be hidden from your view. So this whole diagram shows clearly how that happens. It's in the book, so you would look at it, you will practice drawing this. I hand drew it and labeled it to show you what I expect you to do. So practice this one. This is especially this one is one of those which I ask many times in the test. So it's possible you might get this exact question to be answered in the test. So practice drawing it, practice labeling it. Here's another one. Why is the sky blue? Why is the sky blue and why are sunsets red? Okay. I can't explain it all because you have to go step by step by step. This is from chapter 5. It explains that, but just give you an example of what kind of diagram is expected. So when I say diagram question, yes, you will draw a neat and well-labeled diagram, but you may also have to write some lines there to explain what you're explaining. All right. Those are the diagram questions. diagram solutions example. Some students who come to this class are a little bit scared of math and don't want to see a lot of math and are curious how much math they will encounter. So it turns out somehow the first chapter of this course has quite a bit of math. I might say it has the most amount of math. So you might feel intimidated a little bit in the beginning, but once you get to the next chapters, it's more, verbal, conceptual kinds of things. But there is one formula called small angle approximation, and there are a few questions based on it. So here I've written the solution to one of those questions here. So you can just look at the solution and understand how that works. I've tried to provide quite a bit of help for that concept. I've provided study guides. So for the first test, the study guide, these are all the topics you should be sure when you are doing your preparation, that make sure you have covered these topics. Questions with diagrams, the kinds of diagram questions you can get. These are all their topics. Okay. Similarly, there is a test 2 study guide and test 3 study guide, and the final is combination of all of them. All right, modules here. Let's go to modules. So when you go to the modules, especially the first module, welcome, and then chapter 1, it has a lot of interesting or useful introduction. And then there are these videos. This is lesson 1, Introduction to Astronomy. Some external links to refresh your math. And then here is the PowerPoint presentation. I teach another course called Astronomy 100. And sometimes the initial chapters, the first chapter is the same for both of them. So sometimes you might see those numbers like Astronomy 100 written there. I've tried to fix that, but sometimes it just gets left there. So don't worry too much about that. So here's the PowerPoint presentation. And then all of these topics are also in the book. So you'll read this, you'll look at the presentation that I've done. And then if you want to explore that in more detail, you can basically look at the diagram and go find that in the book. Many times there is even a number here, figure 1-14. So find that and read that in more detail if you need more detail. All right, at the end here, there's a nice summary of key ideas. That's that. and then take the quiz, right? Allowed attempts for points 20. And so here you go. These are multiple choice questions. Pick your answers. I'm just randomly clicking them. And then you can submit it. Okay, this one says 1 out of 1 points. That means this one was answered correctly. This is 0 out of 1. That means it was answered incorrectly. So I would have to look at this one. How many arc seconds are there in a full circle? Did somebody read this ahead of time? Does anyone know the answer to this one? How many arc seconds are there in a full circle? Anybody?
It's the bottom answer, Professor, which is 360 times 3,600.
Yeah. So what happens is in astronomy, we make use of angles to measure things. In order to measure angular size, there's a thing called angular size. So for example, when we look at the moon, one way of measuring the size is how big it looks. We are not talking about how big it actually is. We are talking about how big it looks, how big the Jupiter looks, how big the sun looks, how big the moon looks. And a way to measure that is through angular size. And angular size is a measure of the angles. So here is the moon. And if you just draw an imaginary line from here to here and another line from here to here, and this touches the sides, and then think of what angle this is. In the case of the moon, this turns out to be 1/2 degree. It's quite small, even though sometimes you look at the moon and you'll feel like, wow, the moon looks so big, but that is only 1/2 degree. Okay, so everything, if moon is one of the biggest things that we see in the sky, if that is 1/2 degree, what about other things? They are going to be even smaller, right? And actually, moon looks 1/2 degree and the sun looks 1/2 degree too. The sun is 1/2 degree too. It's bigger, but it's also further away. So it's quite a coincidence. It's quite a coincidence that both of them are 1/2 degree. How do we know that they are equal? We know that from total solar eclipse. When a total solar eclipse happens, it happens because the moon moves in front of the sun. Here's the sun, you're looking at the sun, and the moon moves and blocks the sun. And when it blocks the sun, it blocks it completely, not halfway. It blocks it completely. That means that the disk of the moon is equal to the disk of the sun. Okay, and so from that we know that both are 1/2 degree. But if we want to be more precise, then we want to have further subdivisions. So 1 degree is equal to 60 arc minutes. Arc minutes. And 1, and this is the symbol for arc minute, like apostrophe S over there. That's the symbol. 1 arc minute is equal to 60 arc seconds. 2 of those is arc seconds. So you will notice that this is the same kind of arrangement as we have for the clock. 1 hour is 60 minutes, and each minute is 60 seconds. So in the same way, 1 degree is 60 arc minutes, and each arc minute has 60 arc seconds. So 1 degree has how many arc seconds then? It's the same as the number of seconds in an hour. How many seconds are there in an hour?
60.
60 seconds in 1 hour?
Sorry, 360.
60 times 60,
360.
3,600. So each degree has 3,600 seconds. Right? 1 degree is equal to 60 arc minutes times 60. Each arc minute has 60 arc seconds, so 3,600 arc seconds. So if 1 degree is 3,600 arc seconds, then how much is a full circle? Full circle is 360 degrees. So you multiply 360 times 3,600. That will be the total number of arc seconds. So for some of you, this may be easy, but for some of you, it may feel a little bit challenging in the beginning. But like I said, the first chapter has the most amount of math, but afterwards it gets to be less mathematical. All right, so in that way, you answered those questions and then correct the ones that you didn't get right. Okay, so we talked about quizzes, syllabus, modules. Let's see. There's one module for each one. There is an overview. There is a PDF for the PowerPoint presentation. There is a quiz. There are lecture videos. So that's pretty much common for all of them. There is a poster project assignment details module. Okay. Here's a little YouTube video. Here's a link for a little YouTube video which shows you how to, once you have made a recording, you have the video file on your computer, how you can put it on YouTube. And then if you don't want everybody else to see your video, you can just set it to private or something and just make it so that only, you and I can see it. All right, so there's that. Actually, let me play it.
How to upload a video to YouTube, a quick tutorial. Now let me show you how quick and easy this is. Let's start a timer to see 3:45 and you want to put an actual video title, you can just update enough. This is how quick and easy this is. Let's start a timer to see how long it takes. So from youtube.com or YouTube Studio, you can upload your video. Click on the create icon, click on upload video. And then from here, what you want to do is to go to wherever you have the file saved. Here is one of the videos for our personal finance channel, Greater Than Enough. This is recorded in 1080p. It's around 8 minutes, so it's close to a gigabyte. We'll see how long this takes to upload. The video is going to start to upload. YouTube will take whatever you have for the video file name and add that to the title. this is what I want to call the video, so no need to change it. But if it's like C345 and you want to put an actual video title, you can just update this however you'd like. The next thing to do is to fill in the description. We already wrote this in Notion where we manage all our content. So I can open up Notion, copy the description, and then paste it in like so. After the
all of this
description,
part
we'll
is
scroll
not
down a bit
necessary.
further. Here's where you add your thumbnail. You don't want to use the 3 options below that it just.
Are you guys hearing the sound that's coming from the video? Yes?
We can
Yes.
hear just
Yeah.
fine.
Okay.
Pulled in from your video. You actually want to go and create your own thumbnail. We have a tutorial for that. I'll put it down below in the description. Here is our thumbnail. Open. There we go. Scrolling down further, here's where you add the video to playlist. So this is a video about a updated credit card.
Anyway, so basically hit the add video link, select your file, put it on there, next, and basically it will be ready. So it's quite easy to do, and it's much easier than messing around with Canvas. If you have still have difficulties, you can talk to
Okay.
me. Here's the rubric. And before I talk about the rubric, let me just show you what the what the posters look like. So you can get these are called trifold posters. You can get them at Walmart or Hobby Lobby. I think maybe even dollar store. I'm not sure, but you can get that, and you can just take a look at what it looks like. You can print some information, paste them in a nice way. For astronomy, I've found that these black backgrounds with some sprinkles on it and other things makes them give a astronomy look. So you may want to get a black background trifold poster and put some diagrams, put some pictures on there, right? Here's another one that was pretty well done. So I posted it here. You can, again, look at them to get ideas. The rubric has 10 points, 4 points for aesthetics. The poster should look neat, tidy, and presentable. Any special features like 3D effects, 3D models, drawing or painting made by you for the poster will carry extra weightage. Try some creativity. So, I've put this on here. Many of you are not astronomy majors, but you are other majors also. So I give you a chance for creativity. If you do some painting, art, something, some of these, instead of pasting a picture, you can, hand draw it or do a painting or something. You can just, or you can do some 3D effects here. This is Pangea. I don't know how many of you have learned about this, but the tectonic plate movement, it is said that the different continents, those are like tectonic plates, and they were all together once, and it was called Pangea, and then they moved to be separate. If you will look at the map of South America and the map of Africa, you will see that they fit very nicely with each other, and they were together once and then they separated. So this girl who made this poster, she had these different continents and attached with these thumbtacks so that you can put them together and then move them. So that was pretty creative, I thought. So you can make poster like this, and there'll be some points for aesthetics, for some points for content. Usually I found students are quite nervous about what I should put there and what I should not. I say it is not possible to cover everything on the topic. Just pick 5 to 6 different aspects and describe them. Instead of like filling it up with just tables and numbers, pick 5-6 different aspects and describe them. And I'm not going to penalize you for missing this or missing that. There isn't anything in my head that this is what should be on there. It's just that there should be 5-6 important aspects and describe them. Okay. And then presentation. Topic in detail and kind of assimilate it, understand it thoroughly. And so when you're presenting, I want that you should be able to just kind of glance at the poster, point to things, and say things as if you know them in your head. I don't want you to have a script and just look at that and read it. That's that becomes very clear when you do that, and at least that is something I can see directly, and that causes you to lose points. So practice it in such a way that you have memorized the material. You can have a small like index cards where you have just written like 1 word or 2 word just to remind you, oh, I should talk about this. But you shouldn't have a whole script reading either from the poster or just, separately. So those are the points by which I will decide how many points you get on there, right? And there's 2 posters you have to do. Questions?
So, Professor, what are the topics again for the posters? Are they on Canvas or?
And on the top here, Pluto and moons of Jupiter.
Okay.
Yeah. All right. Well,
Also, Professor, for the exams, are the questions on the exam gonna be the same as the ones on the homework, or are they gonna be like that?
they'll be like the ones on the test and the homework.
Okay.
All right. Well, I think I've said a lot here, and what haven't I addressed about the course yet? Well, in that case, I will